Hello there everyone, and welcome to another edition of Starry Skies, the magazine programme that tells you all about what you can see in the night sky in this month of August. I'm Mark Hardacre.
And I'm Steve Tonkin. And it's great now because after this lovely, lovely summer we've had, the nights are now starting to draw in, aren't they? And
thankfully,
at last, get out under the night sky. I know everybody else think, the days are getting shorter, and we think the nights are getting longer.
Yeah. It's, just thinking back to the summer solstice back in June. I mean, you have to wait until midnight before you can see anything. And then you get maybe an hour of stargazing. It's hardly worth it, is it? Yeah. But August, to me, it's one of the best months to be an astronomer, Steve. I don't know. The nights, it's properly dark again.
Yeah, but it's properly warm as well, so you're not freezing.
Yeah, so you don't have to put all your woolly gear on and your heated shoes and all the other things that we have. And those lovely, stunning constellations, those summer constellations of June and July, are still visible in the sky, but earlier in the night.
Yeah.
So that's really good. Yeah. Also, this is the month, isn't it, for seeing the Milky Way?
Yes, I think so, because, it gets dark. Now we're in August, it's getting dark by 11 o'clock, fully dark.
Yeah, proper dark.
Dark enough to see stuff by about 10, but it's... but you've got this lovely, lovely dark sky, and it's warm, and you've got the Milky Way arching overhead. And if you're down near the south coast, just watch where it falls into the sea, because that's gorgeous.
Yeah, I used to go down to Barton-on-Clay. Is it Barton? Not Barton-on-Clay.
Barton-on-Sea?
Barton-on-Sea, that's the place. Not on Clay, that's up in Bedfordshire. Yeah. And stand there on the coast, gazing out to sea. The nearest place that you can see in front of you is Cherbourg.
Yeah, but 60 miles away.
60 miles away, so it's black looking south, and the Milky Way seems to dip into the sea there, doesn't it? It is brilliant.
Well, one of our great nightscape photographers in the club, she tends to go down to the coast at this time of year.
She does.
It's got lovely images of Milky Way dipping down over Durdle Door.
We'll give her a name plug. That's Louise McKenna. If you see Louise's photography around ever, she's one of our best photographers. She's excellent, isn't she? So, but of course, to make sure you can see the Milky Way, you do need a dark southern sky, and you need to avoid the full moon, because it washes out the Milky Way. Yeah. And this month, the week around the 7th is when the 7th of August is when the moon will be at its brightest, with conditions improving thereafter. And the moon is new again on the 23rd of August. So anywhere around the full moon, just forget it, really.
Unless you want to look at the moon, which of course is always worth looking at if there's nothing else.
That's true. And many people say, oh, it's the full moon. Can we have a look at the full moon? And it really isn't the best time to see it, is it?
It isn't, but what I've found, if you do want to do it, if you've got a red filter, and it makes the moon look horrible, in a sense, but if a red filter tends to bring out detail on a full moon.
Okay, so at least
you
can
do that with a naked eye or with a telescope, binoculars. Yeah.
But at least you can see that big, bright crater Tycho. That's most obvious at full moon.
Yeah, and the ray, it seems like it's got rays coming out, so over about a third of the moon's surface. It's
lovely. So what else we got this month then? Got the usual roundup of the planets to talk about, and what about our constellation of the month?
Well, we're going to look at a little one. It's very little, but it's very, very obvious at this time of year.
Yeah, that's Lyra, the lyre, which is overhead, so we'll be talking about that.
Yes, that's lyre as in the instrument, not something that passes on fake news.
That's right. Anyway, so rising around 10 p.m. by the middle of the month, we do welcome back to the night sky the ringed planet Saturn. We haven't seen Saturn for many, many months, have we?
Well, yes, it's disappeared into the western sky, and now it's rising into the dawn again. So it's lovely. It's not at its brightest because its rings are only just past being edge on, but they'll widen up over the next few years. It'll get brighter and brighter and brighter.
But the good thing about it, it's in a part of the sky that there's nothing else there.
Well, yeah, you can make out the square of Pegasus, which is fairly obvious, almost square group of stars. And below that, there's only two bright things below that, really. There's Saturn, and the next brightest one is a star called Fomalhaut.
Right. Well, where would I find Pegasus then? Say at 10 o'clock or 11 o'clock in an August night, where would I be looking to find the square of Pegasus?
Look up in the east,
eastern
southeast,
sky,
and
right.
it's just sort of hanging there, a square of stars. It's just lovely.
And then Saturn is below that, nearer towards the horizon, on its own, with nothing else around, more or less.
So it's anything that bright by itself is pretty obvious.
Right, but it's not as bright as Venus or Jupiter, is it?
Oh no, nowhere near as bright as Venus or Jupiter.
So it gets brighter as the rings open, and then dimmer as they fade. That's right, isn't it?
Because the rings actually reflect light. So if they're reflecting light back towards us, which is what happens when they're open, then it tends to be brightest.
But we've got to wait a few more years. I think another 4 or 5 years before they're fully open again.
Yeah, but it's a 28, 29 year cycle Venus has, so sort of a quarter of that from now, and the rings will be open.
So we'll get it seeing brighter and brighter, and we'll see Saturn all the way through the winter time, into probably January of next year, I imagine, before it disappears behind the sun. So we've got all the winter to talk about it.
Yeah.
We'd probably have a session talking about some of the moons of Saturn as well. It has the most moons now of all the planets in the known moons, let's put it that way.
Known moons, yes.
Yeah, I'm sure Jupiter has a ton more that we haven't found yet.
Jupiter's easier to see the moons because it's been closer, and we've had more probes go and look at it.
Right.
Jupiter has 95 at the moment.
As of today. I mean,
this has actually been almost a year now. So we've only known of 95.
Right.
So that's pretty good. In fact, there was a crossword clue.
There was
at the weekend.
There was
on the answer was, the clue was a moon of Jupiter named after one of Zeus's lovers.
Yes.
The thing is, all the named moons of Jupiter are named after Zeus's lovers. He had a few.
And I didn't get the answer. What was the answer to that one? Do you remember? Because it's not one of the 4 Galilean moons. It's not Io or Europa or Callisto or Ganymede. I can't remember. It's a 5-letter...
I think it was Tethys.
I think it could have been Tethys.
I think it was Tethys.
Yeah. Anyway, we move along.
We did the same crossword.
We do the same crossword. There are other crosswords available, of course. Anyway, if you're an early riser... So Saturn is in the evening as it gets dark, 10, 11 o'clock at night to the east. But if you're an early riser, exactly that place in the sky in the east is the ideal time to catch 3 planets this month.
Yeah.
Certainly two. As you look around 4 a.m., if you're really an early riser and get up at that time in the first week of August, have a look across to the east, and there you'll see Jupiter and Venus. The 2 most brilliant objects in the sky, apart from the sun and moon, so you can't miss them. And they'll be down low in the east just before the sunrise. They don't twinkle, do they, Steve?
No, they are. That's really easy to tell the difference between a planet and a star when they're bright and low down. Is the stars will twinkle. I mean, sometimes they will flash different colours. Planets are just like they're steady, solid.
And why is that? Why don't planets twinkle?
Well, it's because stars are almost, I know they look different sizes, but to all intents and purposes, they're just points of light, and the brighter ones just tend to look bigger, but actually they're not necessarily. And so the light from there is coming through. It's like a pinprick of light coming through the atmosphere. So if that gets disturbed, then it jumps all over the place. But because a planet actually has size, light's coming from lots of different points on the planet coming through, and if it gets disturbed, well, it still sort of jumbles up. And what you see through a telescope or something like that is it might look a little fuzzier, but it doesn't actually jump around. It doesn't scintillate like stars do.
Yeah. So there you go. You look to the east, and you find those 2 bright objects, Venus and Jupiter. And if you watch them every morning during the rest of the month, I mean, you don't have to do it just for us. We presume that you're getting up for some other reason at that unearthly hour. But you will see that Venus draws ever closer to Jupiter until on the 12th of August, if you can remember. Get up and look, and you'll find that they're almost touching. Jupiter and Venus will be almost touching. Before that, Venus will be to the right and Jupiter to the left. Venus always the brightest, and then on the 12th they come together, and thereafter they'll part, so that then Venus will be the one on the left and Jupiter on the right.
That's right, yeah.
So you'll see them getting, and you really can't miss them, can you?
Oh, no. I mean, they're so clearly brighter than anything else. I mean, Venus is actually so bright that when it's high in the sky, it can easily cast shadows.
Yeah, yeah.
And it's photographically, if you want to photograph it, when it becomes near its crescent phase, because it has phases like the moon, it's actually about 2 photographic stops brighter than the full moon.
Yeah.
It really is very, very bright.
And one of the reasons for that is that the atmosphere of Venus reflects much more light than the surface of the moon. The surface of the moon is grey, charcoaly, coal-coloured.
Well,
close up.
the surface of the moon reflects almost exactly the same amount of light as tarmac.
Yeah. Yeah.
So you say, why does a moon look so bright at night when tarmac doesn't?
Yeah.
Well, actually, it's because your eyes are dark adapted.
That's it. That does
it's
help.
a contrast effect.
Yep. But then what's interesting is joining that party of Venus and Jupiter for a couple of days either side of the 17th of August, so towards the end of the month, you'll have a chance to spot the planet Mercury. Very difficult to see usually, and this is going to be its best time of the year to see it in the morning sky. So look for it on a line through Jupiter. Draw a line through Jupiter, through Venus, and extend that down to the horizon. And there you'll see much fainter and much lower in the sky, sometimes pinky colour, I think, as well. You'll see the planet Mercury, which is the nearest one to the Sun, and tricky to see generally.
It's tricky to see, and if you are using binoculars or anything like that, which does help, just make sure that you've got them away from your eyes by the time the sun rises. You don't want to catch the sun in binoculars, so be extremely careful if you're doing that. But it is gorgeous, and it moves very, very quickly in relation to the others, which is why Mercury, or Hermes, as was to the Greeks, was the messenger of the gods, because it was so quick.
So fleeting of foot, yeah. And if you look specifically now on the early morning of the 21st of August, not only will you have Mercury, Venus and Jupiter, but you'll have a very thin, waning crescent. That's a disappearing crescent of moon joining them. So that'll be a pretty foursome in the sky.
Yeah, because that's only a couple of days before new moon, of course, when you don't see it at all.
And if you're able to capture that with your camera, that we'd be very interested to see. You need to do some preparation, figure out where in the sky this is going to happen, and take your camera on a tripod. But try and get some pictures, and if you get some, we'll share them on Forest FM Facebook page, because that'd be an interesting little combination of Moon, Venus, Jupiter, and Mercury. So see if you can get that.
And that's the one that'll show you how much brighter Venus is in photographs.
Yeah, it will be very difficult to capture Mercury and Venus on the same shot, won't it? Yeah, very, very tricky. Anyway, of the other planets, what about Mars? Have we lost Mars yet?
Well, evening twilight. If you're very, very lucky, you might just glimpse it, but for all intents and purposes, no.
We're done with Mars, really.
We're done with Mars
until next summer.
And we're done with the ice giants.
Yeah.
Uranus and
Neptune. It's going to be interesting, though, because Uranus, when it finally does come back to see us in the autumn time, September, October, it will be very close to the Pleiades for a while. So we'll talk about that towards the back end of the year. But, we'll be able to show you how to find Uranus. It's going to be quite easy. Anyway, last month we looked at Scorpius, did we not? Which is that lovely constellation down on the horizon, and with its brilliant red star Antares. We make no apology, really, for repeating this. It is the perfect time, around 10 o'clock, 10:30, to point your binoculars down towards Sagittarius and Scorpius, there low in the south, and to find the heart of our Milky Way galaxy. It's right there, isn't it?
Oh, yeah. It again, we'll repeat this, it looks like a cloud in the sky to the naked eye.
Yeah.
And it's really, really lovely. In binoculars, you'll get more stars in one field of view than anywhere else in the sky.
Yeah,
it's just
absolutely.
And this, of course, is what helped Galileo to realise what the Milky Way was when he turned his not very good telescope towards the stars, towards the Milky Way, and realised it's not a smear of white milk smeared across the sky or anything like that. It's actually loads and loads of stars.
Yeah. hundreds of thousands of millions of stars all in our galaxy.
But in the Milky Way,
Yep.
just next to it, is our constellation of the month.
Right. And that is called Lyra, right? What's a lyre then? What's a lyre look like?
It's like a sort of mini harp. I mean, it's I actually have a lyre at home.
Oh, really?
Yes, I do.
There's so much about Mr. Tonkin I did not know. It's such a...
Oh, it's a pentatonic one, so no matter how you play it, it always sounds like you're playing a tune because all the notes work together. And it's like a small harp. The one I have is probably about 18 inches long and a foot wide.
Right.
And you just sort of hold it in one arm up against your shoulder and just pluck it gently and send out beautiful music.
But this particular lyre, the one that is in the heavens, almost directly above us, that's associated with Orpheus, right, of the underworld fame?
Orpheus of the underworld fame, and also Orpheus, basically the Greek patron god of music.
Yes, he was.
He was a fantastic musician and apparently singer. Beautiful sounds.
So apparently he played such hauntingly beautiful music that it charmed everyone who listened. He was one of the Argonauts. Do you know that? He was actually on the great ship Argo with Jason.
That I did not know.
And he was the guy, he played the music, and it quietened the Sirens, who were otherwise calling to bring the sailors to their death. I didn't know that either. But just
what you learn on this program.
What you learn on this program. But Lyra, how could you find, when it's such a small constellation, where can you find it then if it's so small?
Well, once you're sort of around about 11 o'clock or so, there's 3 pretty bright stars close and up above, and the highest one, the brightest one of the lot, is a star called Vega.
Right.
And Vega is the principal star of the constellation of Lyra. So you've got that. It's a brilliant white star, and just below it, to one side, there's a little parallelogram, like a little offset rectangle of stars just below it, and slightly dimmer stars, and that's how you recognise Lyra.
Yeah.
It's very easy to recognise once you've got it.
Yeah. And it's directly overhead. More or less, if you lie on your back, look up in the air, you can't miss Vega. It's a blazing blue-white, massive, not hugely massive, but it's bigger than the sun, almost directly overhead. You can't miss it. And the reason it's so bright is it's one of the nearest stars to us in the sky, right? So
it is.
Only 25 light years away.
So what does that mean?
So 25, yeah. People ask me, is a light year the same as a year? I say, no, a light year is a measure of distance. So it's so many millions and billions of kilometres to Vega that mankind can't understand that. Yeah. So we use the light year. That's the distance that light will travel in 1 year. So that's a certain number of thousands of millions of kilometres. Yeah. But for ease of calculating, we say it's 25 light years away.
To get an idea what a light year, how big it is, light will travel 7.5 times around the Earth at the equator in a second. 186,000 miles in 1 second. So you just multiply that by 60 times 60 times 365 or whatever. Yeah, we get there. It's a huge number of kilometres. Yeah, there's a 24 in there somewhere as well.
There is.
It's
But so Vega, when we look at Vega, we know that the light from Vega that we're seeing tonight actually left us sometime around the change of the millennium, around 2000. And it's taken all that time for light to get here. But because it's so bright, and I didn't realise this as well until recently, because it's so bright, Vega is one of the most studied stars in the sky. Did you know that?
I didn't know that.
Yeah.
But it's... it would make sense, because if it's so close, it's easier to get its distance precisely.
Yeah, and it was, in fact, the first star to have its distance measured. You imagine, the Earth is rotating around the sun once every year.
Yeah.
So from January till July and back to January again, it's gone the distance to the sun times 2.
Which is about 186 million miles from one side to the other.
So when you look at a star that's fairly close by, there's a parallax shift. The position of Vega seems to shift ever so slightly in the sky, and by measuring that angle of shift astronomers in the last century were able to estimate its distance away, and that's how we got 25 light years. We know it much more accurately now, of course. So it was the first to have its distance measured by parallax. It was the first star also to be photographed. I didn't even know that. Obviously, it's bright enough to for its light to impact on a photographic plate, Steve, I guess. And then have its spectrum recorded. So
you split its light. Well, now you probably did it at school with a prism, but we actually use little things called diffraction gratings, which are slightly more precise at what they can do.
Yeah.
And and then you can look at the spectrum. And once you've got the spectrum, it has little bright and dark bits in it, which give you a clue, or in fact, more than a clue, it's a fingerprint of what's going on in the star. So you can see what elements are there. It's an absolutely magically beautiful system. In fact, without spectroscopy, we wouldn't know half of what we do.
Yeah. And indeed, it's told us that if we look at Vega with its temperature of around 10,000 degrees, it's such a hot star. It's about double the mass of the Sun, but only the 10th of its age. So it seems to be chewing through its fuel rather more rapidly.
Big stars don't last as long as small stars.
Right.
So the whole thing is driven by gravity.
Right.
So a big star has more gravity, more mass, therefore more gravity, and that's what drives ultimately the whole system, so it gets through its life much, much quicker. So
the Vega is going to burn out much sooner than the Sun, right?
Oh, yeah. Much, much, much quicker.
Yeah.
If it's, I think about 4 times, is it 4 times the mass of the Sun? I can't remember.
Yeah.
Could be
times, I think.
Could be more than that. But you take that, it will last, if it's 10 times the mass of the Sun, you can expect it to last only about 1% the length of the Sun's lifetime.
1/100th of the Sun. Yeah. So massive stars, although they're like actors on stage, aren't they? They go out in a blaze of glory. They're on stage for a very short period of time.
Astronomically short.
Astronomically short.
We're still talking about a billion years down the line.
Yeah. So, but a billion years, where the Sun probably has got 5 to 6 billion years left at least. So the bigger the star, the more rapidly it consumes its fuel, the more rapidly it runs out of life, and it will end in an explosion in space, not a supernova in this case, but it will produce a planetary nebula, which we'll come to in a second. So if you next to Vega, what about that little double star? That's a lovely star, isn't it?
It's a beautiful one. It's called Epsilon.
Yeah,
and it's
so again, what's this epsilon business?
It's the, I think it's the 5th letter of the Greek alphabet, or 6th, I can't remember. I think it's 5th. And stars were given letters, Greek letters, by a man called Bayer, actually. So the Bayer letters, usually, but not always, the brightest one was alpha, next one was beta, gamma, delta, epsilon, zeta, and so on. But so you need to learn your Greek alphabet, sort of, if you can say that. Anyway, just look to the left of Vega, and there's this little double star you can see with the naked eye. Just there, 2 little stars close together. Put binoculars on them, still 2 little stars close together. Get a telescope that's magnifying about 100 times, which modern beginner telescopes can usually quite easily do. And you may pick up that each of the stars of that double star is itself a double star.
So we have a quadruple star then.
Or it's called the double-double.
The double-double, that's it. And you can see that it's right next to Vega, just to the, as we look up in the sky, just to the left, which is, of course, to the east of Vega. And very short distance away. Close by is another one, another interesting star, which is Beta. That's the second brightest star in Lyra Beta.
That is one of my favourites.
Why is it a favourite then? Tell me about Beta Lyrae.
Top left of the little parallelogram I mentioned earlier.
Yep.
And it's not a single star. It too is a double star. It's a very easy one. It is. You've got a yellowy orange star and a bluey white star. So you've got this beautiful contrast in colours.
Yep.
If you want to see the contrast even better, use binoculars and defocus them a little bit, and it really pulls out the colours. It's just beautiful. It's like gold and sapphire together in the sky.
And are those two stars revolving around each other, or are they coincidentally in the same place in the sky?
I think they are coincidentally. They're a line of sight phenomenon. Because remember, what you're looking at when you're looking out at the starry heavens is something that's three-dimensional.
That's it. And what else about Beta? Because that the brightest star of that couple, if you will, is also a double star, isn't it? It's a touching binary star.
Yes.
Touching by. So actually, it's not one blue star. It's two that are orbiting so close to each other once every 13 days that they're almost touching. And that means as they rotate every 13 days, the brightness of Beta Lyrae goes up and down, enough so you can see that in binoculars. And it's interesting that the two are exchanging body fluid. No, I can't say that. They're exchanging mass.
Yeah,
So hydrogen is flying from one star to the other, and I say they're almost a touching binary there. So you can see that with the binoculars. The combined light of Beta Lyrae changes by about a full magnitude once every 13 days. And you can see that change with the naked eye.
You could, Sam, but if you're looking at it with binoculars, just look around it, because there's this rather sparse but rather beautiful little cluster of stars,
Right.
which I really like. It's called Stevenson 1.
Yeah, and have a look for that. That's you need your binoculars to see it, but it's rather nice. Two other things which we need to talk about, and that's the Messier objects in Lyra. The first is the beautiful Ring Nebula, Messier 57, and the other one is a globular cluster, M56. Both of these were discovered, or not necessarily, they were catalogued by Charles Messier years ago. The Ring Nebula looks like a grey smoke ring in a telescope, but when it's photographed, it's great. You really see some lovely colours.
Yeah. And you see these colours in lots of photographs of lots of things, and don't believe that if you got closer to the object you would see those colours. You won't. You're essentially looking at what is a vacuum.
Yeah.
The matter in those nebulae is so diffuse that it's more diffuse in the best vacuum we can get in a lab on Earth. However, because there's so much of the stuff there, it actually is enough that we can see it, and with a camera we can actually photograph it and get the colours as well.
Yeah. And we'll put a picture of M57, the Ring Nebula, up on the Forest FM website, so you'll be able to see that. And what it is, what caused that ring is, exactly as we said before, a star like Vega ran out of fuel, it collapsed in the middle and puffed all its atmosphere into space around it. That was illuminated by the hot, glowing coal that was left at the middle. And if you on a photograph of M57, you can see in the middle of it a tiny little spot, and that's the star that exploded and is illuminating the gas all around. So good to see with a telescope, a biggish telescope. The bigger the better, of course. You can see it in binoculars, but with a nice 6 or 8 inch telescope, you'll be able to see the ring shape.
I mean, one thing you can see with binoculars is you don't see the ring, but what you do see is you see that it's like an out-of-focus star, which is how they get their name, planetary nebula. Because planets look like little discs. Nebula means cloud, so this was a little cloud that looked like a planet.
Indeed. So we've got then M56, that's a different kettle of fish. That's a vast spherical ball of stars, 200,000 stars or so. And that's flying around the galaxy's core, around the Milky Way. You can see that with a small telescope too. It's not very impressive in binoculars. You can see it as a blurry spot. But to imagine that there's 200,000 stars in there, and it's probably nearly as old as the universe. It's about 13.7 billion years old, so it's really old. Anyway, we've put maps of Lyra and the other objects on the Forest FM fan page, so have a look on there, and do have a look for Vega overhead at night all the way through August and into September. Now, normally, just to conclude, we would be talking about the Perseid meteor shower, which is always at maximum in August, but not this year, Steve.
No, moon's in the way. Got a very, very bright moon. You'll only see the brightest ones. I mean, have a look. Please have a look. It's always nice to be out on a clear night anyway at this time of year, as we said. But don't be disappointed if you don't see many.
12th of August is the usual maximum, but it's pretty close to a full moon. So we'll wait until December when we'll look for the Geminid meteors, which are even nicer in my opinion. But
yes.
There we go.
Best meteor shower of the year.
Yeah. So all these constellations and objects that we mentioned can be seen on our monthly sky chart, which you'll find on the Forest FM fan page, as well as online at Fordingbridge Astronomers and Wessex Astronomical Society. Our chart shows the stars around the 15th of August, around 10 p.m. And if you're interested in finding out more about astronomy, do contact us at our local astronomy clubs. Fordingbridge Astronomers meets every third Wednesday in the month at the Elm Tree in Hightown in Ringwood, and we would love to see you.
And yes, and the Wessex Astronomical Society meets at the Allendale Centre in Wimborne on the first Tuesday of the month.
And finally, Cranbourne Chase Astronomy Club meets at the second Wednesday of the month at the Grosvenor Hotel in the centre of Shaftesbury. All three welcome new members. You don't need any expensive kit, just general interest, thirst for knowledge, and one human eye. Two's better.
Yep.
So thanks for listening today. We will look forward to seeing you next month. Have a nice, warm August. So it's goodbye from me, Mark Hardacre.
And from me, Steve Tonkin.
And as usual, clear skies.